Okay, today we're going to talk about transformations and specifically about the quadratic family. This quadratic family phrase is another way that math people like to say that we're talking about things like y equals x squared. So we know that y equals x squared is a parabola. That's that U-shaped graph. It could be opening up, could be opening down for us. And we're going to talk about today, kind of like we did with the super secret notes in the V graph, and how we move things left and right, up and down, that kind of thing. We're going to do the same type of thing today. So we have some vocabulary first, and then we're going to do some of that stuff. So first of all, a transformation is a change in location or size of some type of graph. So we talked a little bit about this earlier, where we took a line and we moved it around, either left, right, up, down. We did an absolute value graph. That was the V-shaped graph, and we did some examples with that. Not only can you just move it around, but you can also make it steeper or wider kind of thing if you wanted to. That's another kind of transformation. That would be a size transformation. Parabolas and quadratic functions. We talked about that these are the ones that up above in the orange are the ones that are like y equals x squared. Those are the parabolas. Sometimes they call it quadratic, sometimes they call it the parabolic, sometimes we call it the x squared. We know that nowadays we also talk about it as an f of x kind of thing. So we could maybe write f of x equals x squared. And just like we wrote up above, these are the U-shaped looking graphs that maybe open up or down as far as we know right now. A line of symmetry is what I like to call a mirror. It's where we can fold the graph in half. So for example, if I'm looking at that parabola and I want to talk about the line of symmetry, I would tell you that the line of symmetry was right here. And then notice that it goes through the vertex. So that's kind of important. So a line of symmetry is kind of like a mirror. It's where you can fold your graph in half and it goes through the vertex. And speaking of that vertex, the vertex is where your maximum or your minimum occur. So if I look at my graphs of my parabolas, the one that's opening up, the minimum would be here. So that's where your vertex is. And if I looked at the one that was opening upside down, the maximum would be here. So that's where your vertex is. Okay, so a parent function is a function that we alter to transform it. For example, y equals x squared would be the parent, and we could change it to y equals x squared minus 3. What happened to the graph?
It translated.
How about it went down 3? the family of functions that's next is talking about all of the new functions created from the parent function after it is transformed. So when I look at that y equals x squared, and I move it around, no matter where I move it, if I create 5, 10, 12 different graphs, all of those graphs are considered part of the same family because they all began with x squared and were just moved around. That's a family of functions. The quadratic. So this quadratic function, the x squared function, has a general way that they write it, or a standard way that they write it, so you can see how it's been moved around. Kind of like the question that was asked just a little bit ago. And that beginning way that we write it looks like this. So this y equals parentheses x minus h squared plus k is called the standard or the general form of a parabola. And the h and the k are where your vertex are. So they talk about this hk thing. That's the vertex. So usually if we just have y equals x squared, that's at 0, 0, because there's no h, no k that we can see. And when we move it around, then that thing changes. So this hk is talking about the vertex that we begin with or where we end up. And what I'm going to do is I'm going to show you some examples of how that works so you can see what's going on with the movement. Kind of like what we did earlier where we did transformations with the absolute value. So let's look at some examples. So all of the examples here, we see a graph that's a parabola. It's the parent graph. It's the graph of y equals x squared. And what we're going to do is we're going to talk about what happened to it and rewrite it with its transformation. So in letter A, what I noticed is that this vertex has dropped down 4 units. And if we remember from the last time we talked about transformations, whenever something moves up and down, that happens on the outside of the grouping symbol. So the way that I would write that is y equals x minus 0, because it didn't go left or right, squared, and then it dropped down 4, so I go minus 4. That's it.
Do you need minus 0?
Nope, you do not. In the second one, I noticed that my red graph, the new graph, has moved up 1 unit. So I'm going to write down y equals parentheses x minus 0 squared. You don't necessarily need the 0, but it definitely helps to see what's going on.
So if you didn't write the 0, would you just do x squared?
Plus 1. If you're not writing the 0, you just have x squared. Correct. Now in the first one, if you're trying to understand what that means, of course that my vertex now is at 0, negative 4, if I wanted to talk about that. In the second one, if I was talking about my vertex, I would tell you that it's at 0, positive 1. So in each case, the vertex is telling you how to write the equation. Letter C is a little bit different. In letter C, my graph has moved to the right 2 units. So now, this is not an up and down movement, it's a left and right movement. So I write down y equals parentheses x. And remember that things look opposite inside the parentheses, so this will be minus 2 squared. And if I wanted to, I could write, but you don't have to, plus 0. And this is because my vertex is now at 2, comma 0. So this stuff works just like we talked about before with lines and the absolute value. Stuff that's on the inside is left and right. Stuff on the outside is up and down. In letter D, I notice that my graph has moved 1, 2, 3, 4 units to the left. So my equation would be y equals parentheses x plus 4 squared. And then it did not move up or down, so I can put a plus 0, not necessary. You would not be marked off either way. And that means that my vertex, of course, is at negative 4, 0. In E and F, kind of the cool thing is they do a combination. So I notice that in E, I moved left 2 and up 2. If I was writing this equation, I would say y equals parentheses x plus 2 squared, and then plus 2 more. So inside stuff is the left and right movement. It looks the opposite of what you think it would be. And the plus 2 on the outside means it went up 2. It looks exactly like you think it would do. And this means, of course, that our vertex is at negative 2, 2. And then the last one that we have, the vertex has moved to the right 4 and down 2. So this one would be y equals parentheses x minus 4 squared minus 2. And that's because our vertex is at 4, negative 2. So inside grouping symbols is left and right movement. Outside is up and down. Don't forget the square on the parentheses. If there's a 0, you do not have to include it. It just helps me to see what happened and helps me write the vertex later. So sometimes I like to include it. Kind of the cool thing in the number 2 example that we're going to do with just 2 graphs is they don't even tell you what this thing is. It's kind of just a weird thing. And what they're saying is draw the graph of what they want you to do with the function based on what you already know. So what you see is considered the parent function. It's where you start. And then the instructions tell you what to do with it. So I look at my first instruction, and this first instruction here is telling me to do something. What is it telling me to do? Go left 2. Because it's inside of the grouping symbol, and it's the opposite of what you would think. So you see a plus, you think, oh, maybe that's right, 2. But no, it means move everything left 2. So I take this graph that they gave me, and I just move it to the left 2. So this point goes to the left 2. This point, see, goes to the left 2. This point goes to the left 2. This point goes to the left 2. And I just redraw it. Done. And the last one's the same kind of thing. I just got to know what to do with that thing. So I look at it and I go, okay, it's telling me to do something with this graph. This one is telling me to move right 1 and down 3. So I look at that graph and I move every spot on it, right 1, down 3. So to the right 1 and down 3 is over here. To the right 1 and down 3 is over here. To the right 1 and down 3 is over here. And right 1, it's hard for me to see, I'm sorry. Right 1 and down 3 looks like it's over here. And so my new graph looks like this. Everything moved to the right 1 and down 3.